Alrighty, happy Monday. So pretty standard week here going on through. So we've got 9.2 today, which is going to be all about lines of best fit and prediction equations. Then tomorrow we'll supplement that with some more work. Wednesday you'll get a work day. Thursday we'll go on to 9.3, and then on Friday you'll have a quiz. And working towards on the 21st, which is the Thursday before Memorial Day, that's going to be when your Unit 9 test is. Okay? All right? So we are in your notes today. So I should see note sheets out, homeworks away. Okay? We're going to start on page 11. So on page 11, there's a couple of finding me the distances between 2 points. We don't have to worry about this. What does it mean to find the average? What does it mean to find the average? The middle number, right? Okay, we're finding the middle of two values, or of however many values, so we don't have to do that part. And then number 4 down there at the bottom is solve a system of equations. Okay? So I'll give you a couple of minutes to get those 3 problems done. Distance between B and F. What do we got for a distance between B and F? 8? No. Between C and E. 9 for that one. Okay, I like that. Okay. Bigger one minus the littler one. Okay. Always. Or if we went little one minus the big one, then you'd have to just get rid of the negative. Okay? Okay? Love it. Which method of the 3, well, actually, first off, before we even do what method we use, what are the 3 methods to solving? Substitution, elimination, and graphing. Yeah, substitution, elimination, graphing. Which method do you want to use? Elimination? Okay, elimination is my favorite. Okay? All right? What variable do we want to eliminate? X, okay? If I'm going to be eliminating X, I'm going to take this bottom equation and I'm going to multiply it by 2. So that gives me 4x plus 6y equals 46. Then I can rewrite the top equation. And now what can I do with both of those? Add them together. Okay? When I add them together, 4x plus negative 4x makes it go away. That's the elimination part of elimination. Okay? 6y plus 5y is 11y. 46 plus 20 is 66. Okay? Now what? Divide by 11. So what's y equal to? 6. Okay? So if y is equal to 6, now what do we do? Either one? Plug it in for y in either one? You want to go top or you want to go bottom? Bottom one. Okay? So that would be 2x plus 18 equals 23. Subtract 18. Divide by 2. And I get x equals 5/2. Now what do we have to do? Both of them back in. Where? No.
Oh, that's a short hit.
Okay. What are we going to do now? I gotta plug x and y into both of my equations to make sure I'm right first. Okay? Because it makes sense to know that we're right first before we just blindly just throw stuff on the paper. Okay? So I would go -4 times 5 halves. -4 times 5 halves is -20 halves, which is -10, plus 5 times 6. 5 times 6 is 30. -10 plus 30 is 20. And 20 is equal to 20. So it works out there. 2 times 5 halves is 10 halves, which is 5. 3 times 6 is 18. 5 plus 18 is, and 23 is what I needed to have on the second one. Now, Ivy, now what can I do? What coordinate am I going to make it?
5 halves, comma 6.
5 halves, comma 6. Good refresher on that. Okay? So, on page 12 now, in your note packet, is 2 sets of different data. Okay? So I'm going to let you choose which set of data we want to deal with. We want to deal with the men's data, or do we want to deal with the women's data? Women's? Women? Okay, all right, we'll deal with the women's data. So this is the data that we're going to use here on the right side. Okay? So this is the median income for women from the year 1991 to 2005. What does median income mean? It tells us 2 things.
The average income.
It's not the average income. It's the middle income is one thing that it is. Okay? So it's in the middle of, if you list them all out, it'd be the middle one. Okay? What's the other thing that it tells us? It's kind of subtle, it's underneath, but it's something that you should know, which will help going forward. It's the middle, what was it again? The middle, an I word. No, it's literally up there.
Income.
Income, what's income?
Money.
Money. So what are we dealing with here?
Money.
Money. So am I going to want to have fractions going forward? Or am I going to want decimals? Not to the 10.
100.
The 2 decimal places, right? This is actual. This is real.
I know that
Yeah.
I'm gonna get you.
We didn't make this up. This is real data.
Oh.
Yeah. It's kind of, it hurts my heart too. Don't kid yourself. Yeah. This is real. Yeah. Okay? Yeah, we didn't randomly just throw numbers in there. This is actual real data you can look up on the IRS website. Yeah, exactly. Okay? All right? So, now, okay, back in center now, okay? So we're talking about the middle of the road money, right? Okay? So if we were to put this on a scatter plot, this would be what our scatter plot would look like over here on the right side. It's on your next page. Okay? All right? What we're going to do to this data right now is we are going to estimate and draw a line to model each set of data. So what we're going to do here, what this is called, is sometimes this is called a line of best fit. Okay? That's what it's called sometimes. You're putting a line on your data that best fits it. Okay? Now, what also comes out of that is we're going to make an equation for that line, and that equation can be used as a prediction equation. Okay? And we can use that prediction equation to say what is the median income for the ladies in 2026, if we wanted to. Because we don't have 2026 in our data set. Our data set stopped at 2005. Okay? All right? So, a line of best fit is just that. It is a line on your graph that best fits your data. So, for instance, if I were to put this as my line of best fit, is that a very good fit for my data?
No.
No, okay? Goes nowhere near any of the points, not a very good choice for line of best fit. Okay? So, you kind of got it, and the nice thing is you can use just your pencil too, and you can kind of figure out where it's going by adjusting it on your paper. Okay, just the same as I am. We're not, so you don't have to draw 78 lines. You shouldn't be drawing a line yet, Bennett. Yes, you were. You were literally going to use your curved sunglasses to draw a line right in front of me and telling me you're not doing it. Ay caramba. Okay? All right? So, come on. Get in there. There we go. There we go. What do we think about that for a line of best fit? Okay. What do we think about that for a line of best fit? Well, I don't want to be close enough. I want the best fit. You know what I mean?
Some years going up, some years going down. I'm not sure we can get into that.
All of them. There's only 1 year that it went down. No, that would be 2005.
Oh.
Yeah, do we agree with that? Yeah?
Oh, I was reading upside down.
Hmm?
I was reading upside down. I thought this was 9.
Oh, no. Oh, yeah, that's the downfall with that one. It does start at the bottom and circuits way back up. Agree with that? Okay, all right. So, hold on here now. So I'm going to say that we then are going through this point and that point right there, yes? So find those 2 points and draw in your line of best fit. Daisy was daydreaming again. Draw your line of best fit in using the same points that I did. You can, you don't have to. Yep. Alright? Does it matter that we figure out 2 points that we went through?
Find the slope.
No, what?
Find the slope.
Not so much to find the slope, but even more than that. We're gonna find the equation. And what's the first thing that we gotta do to find the equation? You gotta get 2 points. Yep, okay. So this is the point right here. This would be the year, so this would be the year 1996. Oops, I forgot a 9 in there. 1996, so that was my junior year in college. Okay? And that's going to be the 0.6, comma, $20,957. Okay. This one up here is going to be the year 2004. So it's going to be 14, comma, 23,989. Okay. Step number 1 to finding the equation of a line is find the slope first. Okay?
Which is,
How do I go about finding the slope?
hold on.
Subtract the y's over subtract the x's. Okay?
Oh, wait, that's what you said.
Is it going to be beneficial for us to keep this one in fraction form?
No,
Why not?
because we're dealing with money.
Okay. So we should, if possible, we should round to,
The
oh man, this one worked out perfectly though. I got 30,032 over 8, which is 379. We don't even need to worry about decimals on this one.
other ones you have.
Okay. Okay. Now what?
You find a y-intercept.
Do I have to find the y-intercept?
So with the 379, the how much it raises every year, or
Because it's positive, right? Okay. Remember that. Yeah. What's the next step? How am I going to make an equation? I don't know, Vito. No, we can leave it in 1. So what am I going to use to find that b? Point slope intercept form or point slope form? Which one? Because they're both different. It's either point slope or slope intercept. It's one or the other. It can't be both. Point slope, because I have the slope, right? And I've got 2 points, right? Can't use the slope intercept form because I have the slope, but I don't have the y-intercept. Okay? So which point do you want to use? The upper one or the lower one?
Lower.
Lower one? Okay. All right. So we're going to use point slope form then. So that's going to be y equals y sub 1 plus m times the quantity x minus x sub 1. It was, for the last like 2 months, it's been sitting right here on the board. Okay? All right? Then the one day that we use it, No, we take it off. Okay? So this is going to be y equals, my y value is 20957. My m is 379. My x sub 1 is 6. So I get a prediction equation or a line of best fit of 379x plus 18683. Do we agree with that?
Yes.
Okay. So let's talk about that equation now, because it's different. Meaning, it's telling us some things. What is one thing, Evan, that it's telling us?
It's going up by 359 each year.
What's going up by 379 each year?
The median income for women.
The median income for women is increasing by 379
Per year.
dollars per year. Yep, because that's what unit we're in, right? Okay, yep, because we're talking dollars versus years. Yep, okay. So it's going up by $379 per year. What else is it telling us? 683.
Was like from the start and it's all added on from
When is this $18,683 from, though?
1990.
No,
1990.
1990. 1991 was year number 1.
Oh yeah.
Okay, so this prediction equation, this is important. This prediction equation is for years since 1990. And you have to say that, because I cannot put in 2026 and figure out what the median income in this current year is for women. What would I put in to figure out what the median income is in 2026? No, that's what I just said we can't do. I put in 36 for X. Because it says years since 1990, if I want to run the prediction equation here of what the median income for women is, okay, so my X would be 36 because it's been 36 years since my junior year in college. Yes, it has. Okay, all right. No, was that my sophomore year? No, 94, 90, 93, 94 was my freshman year. 94, 95 was, yeah. So 96, I was a sophomore in college, or excuse me, junior in college.
How many years since high school?
I graduated in 93.
Oh.
What's up? Did you?
No, not.
Oh, well, I'm about to.
Oh, okay, sorry.
Yep.
Never mind.
Just because he's a step ahead of me. So we plug in 36 there, and we go 379 times 36 plus 18,683 83 would give me for a whole year. Yep. I know. I get it. Hey, you're not getting any arguments from me. Okay? All right. What's up?
You said that like the only time, like in the women's one, it went down was 90 or like a 5. How much different are we did the men's one because it dipped like severely than one up low again?
Well, see, the nice part about this line of best fit is it takes it kind of averages out those increases and decreases and puts it all to what it is. So from looking at both of the scatter plots, I would say that they would both be going up. So they would have a positive slope because all of the data, even though it like here it trended down, it still is going up from where it started. Yeah. Mm-hmm. Did you have questions, Fred?
Oh, yeah. So are you?
Yes, I am.
And my dad can.
Mm-hmm.
Good job, Mr. O'Connor.
Thank you. Thank you. Okay. Good to go on that? All right.
Line slope intersection.
Now, how to do this on technology will be the next one. I'm not going to have you get it out because there's a lot to input and all that fun stuff. But I'm going to show you how to do it. So I would expect you to take some notes on it. Okay? So this is I'll get rid of the men's because we were just dealing with the women's. Okay? All right? So here is I inputted the data into Desmos using a table. Okay? So there is, now let me see it. There it is. Okay, so there's the data from the women. Okay? All right? Now, oops, the wrong one. There it is. Okay? So one way of doing it is, let me see if I can command Z that back out of there. Okay? One way of doing it is up here in this corner, up here by there, it says add a regression equation, and that's going to add in a linear line of regression for us. Okay? The other way of doing it, and I'll show you both here momentarily. The other way of doing it is how I showed you the other day on Thursday when we said y sub 1, and then we used that tilde, okay? And then we went mx sub 1 plus b. And when you do that, it also puts in, come on now, come back to me. Why is it not showing? No, it's not. I don't know why it's not showing. Anyways, so it would show you the same thing that one is, because those are going to be the same. Oh, because it's x2. That's why. I'm sorry. I apologize. Now I see why it didn't show it, because it was in the 2s, not in the 1s. There it goes. Now we can show it. Okay. So there's of best fit the regression line for it. Okay. Now from that, oops, let me get my data out of there. From that, okay, you can see that this is actually some pretty strong data, because our line of best fit is a pretty strong prediction equation, because we want it to be as close to 1 as possible, and 0.96 is very close to 1. Okay? When we did the men's in the last class, okay, their prediction equation had a correlation coefficient of 0.79. So it wasn't, because their data is more spread out. Okay? This data is pretty locked in. Okay?
It's like a point, like we did the second point, and it's
But we also did we did 1, 2, 3, 4, 5. We did this one, right?
Oh, so it's like office.
Yeah. Or did we do this one?
I think we did the one above.
Yeah. Okay? Alright? Now, obviously using the technology is going to be more accurate in terms of your lines of best fit, your prediction equations, etc. But you can also still do it by hand.